Here is the solution to problem H5. This is a particle problem, a motion problem with a little bit of a twist. So we have a particle that they call x, and they give us its position function, x of t. Is particle x, this is part A, is particle x moving toward the left or the right at time equals 1? Okay, so here's the big deal. If a quantity's rate of change is positive, that means that quantity is getting bigger. If a quantity's rate of change is negative, that means that quantity is getting smaller. It's decreasing. So, if a particle is moving on the x-axis and its position is increasing, that means it's moving to the right, even if it's in negative territory. If a particle moves from -6 to -2, its position has increased. -2 is bigger than -6, and it's moving to the right. Same thing happens if the position of a particle is decreasing, it's moving to the left. So how do I tell if a quantity is increasing or decreasing? Look at the derivative. So they look at the derivative of x, they find it right here. They want to know, is it moving to the left or the right at time equal 1? So you plug in time equal 1, you get a negative first derivative for x. That means it's moving to the left. Key thing to know. If a quantity's derivative is positive, it means it's increasing. And in motion terms, if you're moving in the horizontal direction, if your position is increasing, you're moving to the right. Okay, at what time greater than 0 is particle x furthest to the left? And then the three words there, justify your answer. This is really an absolute maximum problem for x. When does x attain its maximum value? So how do you find an absolute max? Well, you have to check two things, endpoints and critical numbers. So there is only one endpoint at time equals 0. And then after that, it doesn't say that there's an ending time here. So we're just letting this particle move forever after it gets started. So I have to check, and one thing that's helpful, I think, in this case is an x prime number line, though you can't really use that and only that for justification, but you certainly can use that and refer to it in your justification. But here's my x prime number line. Let me see if I can circle this here. Doesn't seem that I can. I don't know why. So here's our x prime number line. At time equals 0, the position is, what's the x position? 7. And then for this whole time here, it's moving to the left. At time equals 6/5, which we got by taking the derivative and setting it equal to 0, this is where the derivative can change sign at 6/5, and in fact it does. It changes from negative to positive, and then it keeps going positive. So you can plug 6/5 into x and get an answer get a position that's less than 7. Or you can write a sentence that says something like, at time equals 0, it starts at its initial position and it moves left for 6/5 of a second, and then after that it always moves to the right, so at 6/5 of a second is the time that it's furthest to the left. You can also do this as an absolute max-min problem, which is what I would do. I would set up a table and write x of 0, x of 6/5, and then pick the one that's smaller. Make sure you let the grader know that you're checking endpoints and critical numbers. Lastly, part C, this is the one with kind of a twist to it. We have a second particle, y. They give you the position function of that. And then they start talking about a triangle. What triangle? Well, it's this triangle right here. X is moving to the right, maybe to the left. Y is moving up, maybe down. It doesn't matter. But as x and y increase, they make, or as x and y move, the particles, they make a triangle with their positions and the origin. And as these move, the triangle's area changes. At a particular time, they want to know what's the rate of change of the triangle. So it starts by figuring out, well, what's the area of this triangle anyway? Try to write an equation, an expression for the quantity that's changing. And in this case, it's area. So areas of a triangle is 1/2 base times height. Here it is right here. There it is with the x and the y formulas for their functions put in. And now to find the rate of change of that, we need to find the derivative. Just be careful. You either need to multiply this out first and find the derivative, which I wouldn't do, or you need to use the product rule. This is the product of two functions. So there's their derivative with the product rule. And we want to know, so this gives you, this a prime, that gives you the rate of change of the area at any time. We want to know what's the rate of change of the area at time equals 1. So we plug in 1 for t, and we get an answer. And look, my drawing actually is pretty poor because the rate of change of the triangle is actually decreasing. The way I've drawn it with the arrows, the rate of change would be increasing. So it was a good clarifying picture. It helped me figure out what was going on, but it turned out to not be terribly accurate in the context of the problem. That's okay. You don't get penalized for diagrams that you don't that turn out to not be correct. That's just a helpful piece of work for you to understand the problem, but you won't get penalized for that. You don't need to erase it or anything like that. All right, that's H6. Oh, sorry, that's H5.